I had almost finished evangelizing the class with respect to the virtues and glories of the one true religion, C programming. And we had just sort of had a brief discussion of the manner in which, as the C compiler came into existence, the various C compilers there are, and the fact that GCC is of the one true religion, it is the holy book. All others of which are mere pale comparisons. So you'll find as programming C, as you continue on in your path of true enlightenment, which is C programming, you'll find that C does not provide you with a great deal of the sorts of functions that you're used to having in other languages. Python in particular. A lot gets loaded into the prelude, right? In C, you start off programming with basically, like if you just open a C file and start programming in it, basically all you've got are basic language constructs, function declarations, loops, if statements, assignment statements, all of the regular basic programming constructs, but you basically get no libraries unless you import them. Zero. Not even the ability to print stuff to the console. Incidentally, the equivalent in C of Python's print function is printf, where the F stands for function. So it's the print function function. And everybody's okay with that. Because originally they were called subroutines. So, anyway, the most commonly used functions are collected into the C standard library. The C standard library is not just used by C. The C standard library can, at least on, I would generalize that. The C standard library is, this is kind of a debatable claim, but it's part of the kernel. Many, 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 many C functions are used by other programming languages. For example, your beloved Python. When you are calling Python's print function, the Python's print function is in fact calling C's printf function with some fancy schmozzle to handle strings and that sort of thing. Basically, it's printf with implicit string conversion and a few other bits and bobs. The documentation for the C standard library is found at gnu.org/softwarelibcmanual/pdf/libc.pdf. libc is what the Linux/Unix version is called, but I only care about that, so there you go. Use of library functions is strongly encouraged. If there's a library function for it, you should use it. These functions have had over, approximately 50, some of them actually predate C as a language. So they've had over 50 years of development and refinement and optimization to the point where these are the most efficient pieces of code that exist. So to not use them is the height of foolishness. Library functions, especially from venerable libraries, have had decades of optimization and improvement. Rule 1, if the library function exists, use it. Rule number 2, learn rule number 1 quickly. I have a kind of a famous anecdote, or I don't know, maybe it's not famous, but I have an anecdote about a student who gave me a solution to one of the upcoming assignment problems in this class. Basically, the whole point of the assignment is learn how to use the string library and string formatting and all of these various functions. And it was interesting because this person decided to completely forego the use of anything in the string library or any string formatting functions whatsoever. And so, a question, which in my instructor's solution was about 12 lines of code, ended up being more like 120 in this person's solution. And as I'm sure all of you are experienced enough to know, the longer the program is, the more likely it is to have errors. So this person was basically had painted themselves into several corners at once and had no idea how to fix their problem, and they were coming to me and showing me more lines of code than exist in the relevant C library. And I was like, well, I could either spend 3 days trying to understand this, or I could say, well, you could have used these other libraries and made life way, way simpler. Generally speaking, if this class is taking you too long, you're probably not using the libraries sufficiently well. But I don't know. Anyway, so let's talk about some other languages on which C was largely influential. C++, for obvious reasons. So Python doesn't have this operator, but in C, and we're going to see it, the plus operator is the increment operator. What this does is it adds 1 to the variable, and it's an implicit assignment operation. So if you say x++ on one line, x++, that is equivalent to x plus equals 1, right? So, basically, the name C++ is a pun. It's the incremented version of C. So C++ was developed by Bjarne Stroustrup at Bell Laboratories. It's an iterative improvement on C, crucially adding support for object-oriented programming, which C does not have. C is a purely imperative language. Object-oriented design adds the object, a new unit of abstraction that allows the combination of data with functions. I presume that they did a certain amount on classes in your Python class. Yes. Did they beat you over the skull with it? No. Well, they should have. In this class, you're also not going to get very much in the way of object-oriented programming because this is a course on a language which is purely iterative, but sooner or later, you're going to need to know how to use object-oriented programming. So, very broad overview, right? You take data, you combine that with the operations intended for that data, package it up in a class, and you can create instances of that the same way that you create instances of integer variables. And that is the essence of object-oriented programming. It's a mechanism of abstraction that allows you to bundle subroutines and procedures with the data that they operate on. Anyway. Object-oriented programming increases modularization and facilitates programming principles, which allow very large programs to still be workable and manageable. Basically, and you may have noticed this, the larger a program becomes, the more difficult it is to work with. In programming, we have various principles which allow us to manage large programs if those principles are adhered to religiously. One is the principle of modularization. Your programs should be small and bite-sized and do one thing well. And programs more largely construed are composed of small bite-sized programs which are easy to implement, essentially. This is the reason why writing functions is encouraged to the degree that it is. When you write a small module or a class, it constrains the interface to that class. Because the interface has been constrained, it can only be used according to the will of the original programmer. That's the intention anyway. like much of the difficulty in programming comes when people think they're being clever and are using programs in a way that wasn't intended by the original author, right? It's like, oh, look at that, I can just, if I just set this variable at this time in this particular manner, I can like sort of coax this type of behavior out of it, and look, I can use that to some advantage. It's like all of these arcane secrets are only appropriate for speedrunners. If you're actually trying to write a program people are meant to understand, then you provide an interface, you stick to that interface, and and basically programming is hard enough without having to deal with gigantic monolithic piles of spaghetti. Anyway, so Objective-C. Object-oriented language developed in the early 80s and eventually acquired by Apple. Objective-C is essentially Apple's version of C++. So there you go. Java. How many people have used Java? Quite a few. Pretty good. C++ derived language developed by Sun Microsystems in 1991. It uses the Java virtual machine to extend portability to a very large and highly diverse set of architectures. And also it's the language in which Minecraft was written. C# is synonymous with Microsoft's .NET framework. C# is itself a pun on C++, though not as clever a pun as is typical for Microsoft. Note that if you squint at the pound sign, you can imagine it being two pluses on top of each other with the lines mushed together. So it's C++++. So that's how uninteresting and derivative Microsoft is. They couldn't even come up with an original way to say this is the next C++. So non-Microsoft implementations also exist, such as the game object scripting in the Unity game engine. But in general, C# is a pretty good language. Yeah. Anybody use C#? Hey. There we go. PHP, an object-oriented open-source scripting language used primarily in Internet database and Internet database applications. Python, also released in 1991, that is to say in the same year as Java, developed by Guido van Rossum, who declared himself benevolent dictator for life of Python, emphasizes the elimination of superfluous syntactic detail and has become a very popular language for introductory programming courses for some reason. I'm not sure why, but it is what it is, I suppose. So, like, you gotta think of it this way, right? Which is the better language, Java or Python? Given that Java is released in 1991 and dominates the 90s and the early thousands, and then Python is released in the same year and only became popular 5 years ago. Which language do you think is better? At least in the consideration of people who know what they're talking about. Ooh, did I say that out loud? JavaScript, the most widely used scripting language, adds dynamic behavior to websites. And insofar as TypeScript is based on JavaScript, that would also be C-based. So you can see, so to speak, that the number of languages which are C-based is quite extensive. This is a joke about Java and JavaScript being very different languages. As the old adage goes, Java is to JavaScript as car is to carpet. So, compilers then. In contrast to Python, and all that we know and love from whatever the new course code is, that's what it was when I took it, so that's what it is when in my future, like in my parallel universe that I'm operating here, where they never changed the names of the things in the first year program. C is compiled rather than being interpreted. So I've already talked about the difference between a compiled and an interpreted language, but let me just recap that briefly for us at this point. An interpreted language, including Python and Java, requires the interpreter to be running so that the program can be fed into the interpreter and essentially compiled at the same time it's being run. So that is to say, the statements composing the program are not checked for problems or checked for correct typing or anything like that prior to the computer attempting to run it. These languages typically have a much heavier emphasis on what's called dynamic checking. That is to say, things like types and things like syntax, in the case of Python, are being checked as the program runs rather than before you decide to run it. Contrast this to compiled languages. In a compiled language, you separate the process of taking your program and creating the object code from the execution of that object code. They are two separate invocations of two separate programs, right? The first program you call is the one that performs the compilation. The second program that you call is the program which you just produced via compilation, presuming that the program did in fact compile and that an executable was in fact created. The compilation process itself is broken down into many stages, and many of these stages are also performed by the interpreter, right? As you might expect. It's just like, is it being done statically or dynamically is primarily the question. So, the first process of producing a program is, of course, to produce the program itself as sort of the way that we think about it. To generate the C source code from, the problem and your own knowledge of the C programming universe, as well as any bits and tidbits that you've stolen from the internet. Not in my class. So after step 1, sort of step 1.5, we take our source code and we feed it into the compiler, right? The first step of compilation is pre-processing. The pre-processing stage performs a number of functions related to cleaning the code up so that it's interpretable more easily by the compiler. For example, comments, right? You leave comments in the code and you don't think about it, but obviously those comments are not being compiled. They are not proper programming statements. The pre-processing step is the point at which the compiler goes through your file and removes all of the contents. Obviously it does this without writing that file back to, it doesn't overwrite your existing file, obviously, right? It stores your file in memory and further, does further processing on it. But the comments have to be removed at some point, and it's before we get any further, right? There are, in addition, a number of constructs called macros, which we're going to sort of dance around a lot in this class until finally dealing with them right at the end of the course. Macros essentially allow you to perform manipulations of the characters in the file without, performing manipulations of the file itself. So, for example, if there are various points in the file where you want to be able to define that, the size of an array should be some number x, and you want to make you want to set that in one place and use it several places, but you don't want to use a variable for that. You can actually get the C compiler to substitute a group of characters for that number as a pre-processing step so that that never consumes any memory, as an executable, right? So, and all it's doing is it's like doing a find and replace operation over your files. That's essentially what you can think of a define macro as being, is a declared find and replace. But we'll see examples of that, don't worry. So, after pre-processing, we, in theory, have a program which should be interpretable by the compiler, now that all the nonsense fluff has been removed. We pass into a process known as parsing, also sometimes called tokenizing. Parsing is the process of taking a series of characters and identifying what language constructs those characters are meant to represent. So, for example, an if statement is parsed as an if statement, right? An expression is parsed as a series of like nested calls of various operators. So, for example, if I had an expression, and I think I'm going to turn the lights on the chart. So, if I had the expression y is equal to 3 plus 10 times x, there we go, minus y, right? Something like that. Imagining this to be a series of characters, to parse this, we would have, at the top level, an assignment operation having y and then some expression, which is described in a nested manner. So we would have, add 3 and the results of minus y and the results of multiply 10 and x. Right? So it breaks this down into a series of operations. In a technical point of fact, once you want to convert something like this to actual object or machine code, each one of these operations will correspond to multiple multiple CPU operations, right? Like, in order to multiply 10 by x, we must first fetch the value of x from memory, which is a CPU operation. Then we multiply it by 10, which is a CPU operation. Then we store the result somewhere intermediate so that it can be retrieved for the purposes of the subtraction operation, but that's getting kind of low-level detail. So we take statements and we break them down. That's parsing. I actually kind of described the next set of operations, which is assembly. This, by the way, is what's called an abstract syntax tree. When you take the abstract syntax tree and take each node, find its equivalent CPU operations, collect those up into a program itself, that is what's known as the assembly process. You guys following so far? Any questions so far? Am I destroying your brains on this Monday morning? Hopefully I'm destroying them in such a manner they can be rebuilt. Yes? Yeah, sure. So, each one of these operations will correspond to multiple CPU instructions, right? The process of taking this tree and creating a linear sequence of commands which will perform this calculation and then, you know, running that together with all of the other commands generated by all of the other statements in the program, that's assembly. Does that make sense? Good. But an important point to realize about this. This program looks linear, right? Your C program will look linear. It gets parsed into something that's got a tree structure, but then it's got to be re-linearized in order to be executed by the CPU, right? So you have to decide what order these things are happening in. And generally you go from the bottom of the tree to the top. So, linking. When your code uses functions, particularly functions that are not described in the C program that you have written, that is to say, when you use library functions, there's basically a couple of ways of doing it. The preferred way is to dynamically link those libraries to your program. So what happens is, for example, when your program calls printf, right, a symbolic link is left in your program to be resolved when you actually run the program, right? So creating those symbolic links to other parts, pieces of code, possibly in other files on other parts of your system, this is known as linking. After that, so after this point, we are now at the part where we're actually running the executable. After steps 2, 3, 4, and 5, the executable will be produced. You know, assuming that compilation succeeds. The first thing that your computer does when you ask to run a program, it loads that program from your your hard disk or your solid state drive into memory, and then it loads any of the subroutines which are linked to by that executable, right? It gathers up all of the code it needs to operate, and then, and only then, does it actually execute the friggin' program, right? So, to compare this to the interpreters again, steps 2 through 7 are all collected up as, in the space of one continuously operating program. Does that make sense? Any questions about any of that? Yes, sir.
Can you just go over linking again?
Yeah, sure. So, I will use a cookie metaphor. So, let's say that your program is a big chocolate chip cookie, right? Each one of these chips is a call to a function that's not inside this cookie, right? So, it might be referencing several cookies across several parts of the computer stored in various cookie jars, right? So, only when you actually, so linking is the process of creating the chocolate chips in the cookie, right? During loading, the computer goes through this cookie and finds the locations of all of the chocolate chips which basically each chocolate chip has a function name and place written on it, and it goes and it finds the cookies. And then, as you're eating the cookie, when you hit a chocolate chip, you can go and eat this cookie, and then you can come back and continue eating that cookie.
Capiche.
Cool.
So linking is like forming connections to
There we go.
functions.
So,
like that.
in detail, C files may be edited using any text editor. This includes Notepad, Emacs, Gedit, any like text edit. Basically, what you're shooting for in an editor is something that does not do any formatting whatsoever. Formatting, which is saved by the computer, takes the form of formatting tags in the file itself. You want a program that will simply only edit the characters in the file. So these are your options. If you are on Windows, Notepad++ is recommended. The editor in VS Code is of necessity a plain text editor as well, but you know, the compiler that VS Code uses is not GCC and therefore inferior. Fancier environments allow for compilation and execution of C programs within the editor itself, with the asterisk that they sometimes use somewhat dubious compilers. C files are given the .c file extension, and C header files, which we'll get into, have the .h extension. So header files are what you import in order to get access to the C standard library. You can write your own header files. Header files are still C source code files. There was a debate last time I taught C whether or not header files count as C files, because that was important with respect to the interpretation of some assignment or something. And it was like, well, yes, they have C code in them, so they are C files. The .c extension is technically not necessary. You can put C code in a file with any extension and compile it as C code as long as you throw it in, as long as you are consistent about the file endings, then it'll just work. But yeah, it's kind of like file extensions are kind of a lie that have been told to you over the years. They're not nearly as strict as everybody thinks they are. So anyway, the following process describes complete compilation of the following very simple C file. So this is your hello world in C. All right, let's go through the pieces. Include stdio.h. Includes the standard C library for input and output. So printf, the print function, exists inside of stdio.h, and unless you import that, you can't actually print anything from your program. In contrast to Python, where you can just type print. Execution of a C program starts with the execution of the main function. This should be familiar to any of you who have not worked. But any of you who have worked in anything other than Python should know that, program execution starts at the beginning of main. Incidentally, what Python is doing is it's just implicitly wrapping the entire file in main. It's not that Python doesn't have a main function. It's, in fact, if you take a look at what it names your objects under the hood, it's still calling them main.myClass and stuff like that. So main is still there, it's just implicitly the whole file. So that's why Python can pretend that all you have to do is say print hello world, and there's your hello world in Python. It's like, anyway. So the reason main is returning an integer is because this information is being passed back to the operating system. A non-zero return value from a C function or from a C program indicates a non-normal exit condition, which is normally either an error or some other kind of problem. So in this case, return 0 means I ended with no problems. If you can actually leave the return off and it will return 0 implicitly, and that's also, I ended with no problems. However, if you generate an error in here and you'd like to send an error to whoever's using this program, you can, return -1 or something like that. Good. So, in general, this shouldn't be too bad. Like the print. Oh, question.
So the return value doesn't really matter. You're just not 0.
Well, it matters depending on like who's using who's using the program. But yeah, in general, for the stuff we're doing, the return value will be terribly important most of the time. Here's an example, right? GCC itself will return a non-zero value if compilation fails, right? If you're writing scripts for like assuming you're using something like a bash environment where you can actually write scripts to run programs for you, you can test whether a program exited non-zero or 0, and then like branch conditionally on the return result of that, and then perform other programs depending on the results of previous programs executed. So it's very important with respect to the larger integration of the computer itself, but with respect to the writing of an individual C program, all you have to really worry about is, did I make an error? Yes, no, 0, no, not 0 otherwise. Make sense? Question at the back.
Do you need to call it main, or is that just convention?
Do you need to call it main? Yes, you need to call it main. The C compiler looks specifically for the function called main, and it will execute that. And if there's no function called main, it will say, I can't compile this as there's no main function, right? Because here's the question. If no function is called main, which one do you start with? Exactly. Yeah, you would have to make an arbitrary decision, right? And the first function in the file is not necessarily a good decision either. But we'll get into it.
So we could run other functions after main that are not included in main?
Any function which is run must be called from main, or something called from main, or etc.
Oh, I see.
You can define all of the other functions are defined outside of main.
But they're just not running main unless we call it inside of the
Yes. Question? When you're not concerned about its return value. So, void in main means that main doesn't return a value, which means we're not concerned with its output. Here, putting void in here means that your function takes no arguments.
Is it the same as just keeping it without?
Yes, it's syntactically identical to just having an empty brace here. Any other question?
Is that hashtag comment, or that's how you do something?
Okay, first of all, not hashtag,
Sorry.
Octothorpe. Octothorpe is the name of that character.
Okay.
Second of all, the Octothorpe character indicates compiler directives. Technically, this is a pre-processing step. All pre-processing steps start with the Octothorpe character, including the defined statements we're going to see later on. Comments are a little bit different. They're either 2 slashes or /* with a */ at the end for multi-line comments. But don't worry, we'll get there. Oh my gosh. Question? It would just pretend it didn't happen. It depends on the nature of the error, though. Sometimes the error itself is enough to crash the program. Like, for example, if you're writing a program and that program runs out of memory, that will stop your program before it reaches its own return statement. So, and it will return non-zero to, its own subroutine will return non-zero to your whatever you called it. This is really, this is not for system errors. System errors will take care of themselves. This is like the input you gave me wasn't valid or something. Right? Question?
If you include void main, would you have to have a repeat statement at the end? No?
It would.
So the correct way to return from a void function, if you want to use a return statement, is to just say return with nothing specified. Does that make sense? Any other questions? You're going to have to shout.
What are the curly brackets?
Ha-ha! They indicate blocks of statements. This is a primary difference between all sane languages and Python. So Python tells you what things are inside of other things using indentation, right? In C, the indentation is technically unnecessary. It's only for readability. What actually tells you what's inside of an if statement or what's inside of a loop or et cetera, is the presence of these curly braces. Does that make sense? Awesome. Red shirt.
Is the return 0 or return non-zero only like relevant for the main function? Or would it
I mean, that's also the way, like, yeah, it's like if you have just a regular function that main is calling, the return value of that function will be something useful to the thing that called it, hopefully, you know. But no, it's not like passed on to the operating system. Only the return results of main are passed on to the operating system. Question?
When do you close the set of curly brackets and then start a new set? Is it only after return statements that you close?
Normally, after function declaration lines, if statements lines, loop lines. So everywhere that you would use a colon in Python. Cool. Any other questions? Boy, I show like just a hello world and I get like a dozen questions. I love it. No, but I'm really glad that you guys are asking questions. It shows you're paying attention. So, to compile this simple program, we use the following invocation in Bash. If you're using some kind of fancy schmancy IDE where you get to click a play button, this is what the play button is actually doing. Alright? It's making this invocation. So, GCC simple.h output simple. So simple is the name of the executable we're producing. Simple.c is the name of the source code file. So, first, we invoke GCC, the GNU compiler collection. GCC knows we want to interpret the file as a C program because of the file extension, but other extensions can still work. Incidentally, if you want to compile a C++ program, it's G++ is the name of the compiler, technically in the same compiler collection, but anyway. So, we next specify the name of the file to be compiled. The O flag allows us to specify the name of the produced executable file, and the produced file is the original program expressed in machine language, also known as object code. Note that this is different from assembly language. Assembly language is a compiled language the same way that C is a compiled language. The difference between assembly code, assembly language, and object code, assembly language is still expressed in characters. It's a bunch of characters in a file. Object code is binary data, so it's not in characters. It corresponds to the actual codes that you call on the CPU to access actual operations, right? In a binary format. So object code is not interpretable as characters. So let me see if I've got an example of this I can pull up in the next minute.
These files are mint.
Wow, you can.
There's a water. Here apparently a lot of high level officials in Russia called for cyber treason and take that. Like apparently really close to the Civil War and staging a revolution. Fucking great news. Wow. Glad I'm not there. I can't see any of that. Let's try it again.
Alright, so, your attention, I beg your indulgence for for just a few seconds. So here's that file, right? There's the source code. In my terminal, GCC, this is called hello.c, output hello, compiled, execute hello, and there it is. Cool? Any questions? Okay, thank you very much for your time and attention, folks.